Hello, I'm Sam, and in today's video we're going to be going over test case design and more importantly around implicit and explicit assertions. Most of the time in test automation you end up with click click fill click 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 fill assert. Now while this is fine from a functional perspective, you're going through the site clicking and filling as you should, you often leave big gaps. This is where I call it a implicit assertion. So just because the login button is there to be clicked doesn't mean it's in the right place, it doesn't mean it's the right size, it doesn't mean it's got the right text in it. Let's take a look at one of these tests in DoesQA, going from what they looked like before to making some adjustments and what they could look like after. Jumping over into the app, we can see an example of this. This test case is extremely functional. It goes through and fills all the fields in and clicks all the buttons it needs to get to the end. There's a single assertion at the end of each branch, which is a desired end state. Now whilst this is functional, what I call this is implicit. This is implicitly going through and asserting. Just because I can fill the username and password and click submit means that the form must work. But does it mean it looks right? Does it mean it's not been changed or edited, or whether there's even labels on those fields or anything like that? We don't know. We functionally get to the end, which we class as a pass. I've taken this same example and applied some changes to it, and let's walk through those now. Hopping over into the other flow, we can immediately see two main things. One, this flow is bigger, and two, this flow is more colourful. Colourful tests in DoesQA mean better tests. If you have a single colour like in the last flow where it's orange, all you're doing is implicitly checking all the way through till the end that things are working. Having a variety of different node types allows you to assert many different things along the journey. Let's dive into more detail, in particular to the changes I've made to this flow. Starting at the top, I've added name nodes. These allow me to identify the different branches within the results when the test case is completed. So in this example, we've got login here and forgotten password, and then login, login. So when I run this test, I can see, did it go down the forgotten password journey, or did it go down the login journey? I've added some extra assertions before clicking the login button because it might be visible, but might not be clickable. It might be clickable but not visible, so let's do some extra assertions before clicking that node. After I've clicked login, I'm then actively waiting for something to happen instead of passively waiting, right? So when I've clicked login, I'm not just passively waiting for the username to be fillable, I'm actually waiting for it to be displayed before carrying on. So what we've got here is a wait for and then some more assertions. So in this case, the forgotten password, we're making sure that link is clickable, because again, it might be visible but not clickable. One new node type here is our Pally node. You can see the same node down here for forgotten password. These are two different pages that might have different components on them. Therefore, I want to make sure both of them are compliant with accessibility standards. As we keep going down, you can see there's many more assertions in between each thing. And one thing to note at the bottom here is, in the last test case, let me go back over to it. When you've done something like a password reset or a forgotten password or anything like that, most automation frameworks stop there because they're unable to open an inbox or open an email, verify the email content, click the link and go on. Or you do what I call like a bypass test, where you send a forgotten password email but then contact a back-end service to get the reset password confirmation code and then just set it yourself. So instead of doing that, in the second test here, we're actually going and waiting for a new test case email. We're then going into that test case email and then doing visual regression to make sure that test case email hasn't changed. We could extend this test to then scrape the link from the page, assert more on the page, and then go and actually reset the password, but that's a different video. On the other side here, this is where the user's resetting their password after logging in. So again, we've got first Pally check, which is on the login page, and then we've also got a Pally check after resetting the password. There is an additional new node down here, wait for text to equal. Now I'm using this in the case of, for example, when I click password reset confirmation, there might be an asynchronous call made out, and there's no user feedback until you get the confirmation message appear. Now, without this step, you might click the reset confirmation, then straight away click log out. That might be before the call is finished, or the call may come back unsuccessful. So asserting not only that the text appears, but also that the text equals a certain value is great for missing that. So once we've logged out, we make sure, again, more passive and active assertions in terms of making sure the logout is not displayed and that my account is now no longer displayed. A new thing down here for flow optimization and making sure these flows are repeatable and maintainable across different ones is now I'm using a node group to log back in. Instead of logging in with separate nodes on every flow, I've got a group here that does the same steps every time you use the group. In this instance, it's grabbing the URL, storing it, going to the login, logging in, and then go back to the original URL where you started. So this node group can be dropped into any flow, and at that point it will log into the account. And then what we're doing is doing the final assertions. So although this test case looks a lot bigger than the last one, this has a lot more coverage, a lot more active assertions, not passive. It has a lot more functionality checking in terms of actually checking emails are delivered. It's got accessibility testing in it. It's got a little bit of visual regression in it, all within the same flow. The flow has an increase in complexity or run duration. Now, while I'm showing this in DoesQA, many places have this in code as well. You might be just doing click, 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 fill, 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 click, no assertions in between. It's visualized in DoesQA because you can clearly see this first flow has lots and lots of orange and not much green, and the second flow has a lot more colors. In DoesQA, we gamify this a little bit. We use a thing called check ratio. Check ratio takes the amount of orange nodes, the action nodes, and assertions, the green nodes, and compares them together. If you've got a flow full of orange nodes with no green to be seen, that's going to be no checks. Obviously, we don't want that. You can have a few, like this one, only has a couple for many orange. This would be a poor check ratio. You can have an okay check ratio where they're about sort of equal but still not great. A good check ratio, which is more than enough, or great, which is a test case that is full of assertions, really stable, and gives loads and loads of good results. I hope you've enjoyed this video, and thank you for watching.